In this video, we'll be talking on Parseval's formula. What is Parseval's formula? It is a term often used to describe the unitary of Fourier transform. Loosely, that the sum or integral of the square of a function is equal to the sum or integral of the square of its transform. So these are the formulas of Parseval or theorem. So the general formula is given by this. However, for Fourier cosine series, where we have Bn to be equals to 0, you can see that this Bn here is no longer here because it's equals to 0. However, for Fourier sine series, you can see that A0 is equals to 0 and An is also equals to 0. So with respect to that, these two are gone and we are left with just this. So how can the Parseval's formula be applied in the question? And most importantly, the question to be asked is, what is C? You can see minus C here, and see C here, C here, C in almost all parts of the formula. Now, if we are given the range of A less than B, X less than B, then our C is equals to B minus A. We can say it's simply the higher limit, the upper limit minus the lower limit. So in this video, we'll solve a simple question on Parseval's, using Parseval's formula to deduce a function. So the question says, by using sine series for f of x is equals to 1 and 0 less than x less than pi, show that pi squared over 8 is equals to 1 plus 1 over 3 squared plus 1 over 5 squared plus 1 over 7 squared, and it continues. Now, what should we take note in this question? The first thing we should note is we are offering sine series. Our f of x is equals to 1, and this is the range. Now, the first thing to do is to solve the Fourier sine series. And we recall that for Fourier sine series, A0 is equals to 0, An is also equals to 0. However, Bn is equals to 2 over pi integral of 0 to pi f of x sine nx dx. Therefore, we can say that the Fourier series of f of x is equal to the summation of Bn sine nx from n is equals to 1 to infinity. So all we just have to do is to evaluate Bn, and from the Fourier series that we evaluated in f of x, then we will be able to deduce pi squared over 8 to be equals to this. So let's proceed. Let's solve for Bn. Bn is equals to 2 over pi integral of 0 to pi f of x sine nx dx. And from the question, we know that f of x is equals to 1. So we have 2 over pi integral of 0 to pi 1 sine nx dx. Solving this, we have 2 over pi integral of 0 pi sine nx dx. Integrating sine nx, we have minus cos nx over n from 0 to pi. Now let's introduce our upper limit and afterwards our lower limit. So we have 2 over pi from minus cos n pi over n, and the lower limit of 0 minus cos n of 0 over n. Now simplifying further, we have 2 over pi of minus cos n pi over n plus cos n of 0 over n. Now we know that cos n of 0 is equal to 1. However, cos n of pi can be equal to plus 1 or minus 1 based on the value of n. So if cos n of 0 is equals to 1, then this can be written as 2 over pi into minus cos n pi over n plus 1 over n. So this is Bn. Now because of the variation of cos n pi to be plus 1 or minus 1, there is need for us to evaluate B1, and there's also need for us to evaluate B2 and others. So we can evaluate B1, B2, B3, B4 down to B5. Now B1 means putting n is equals to 1, and when we do that, we can see that we can take a moment to substitute n is equals to 1, 2, 3, 4, 5 into the equation of Bn. And we realize that B1 is equals to 4 over pi, B2 is equals to 0, B3 is 4 over 3 pi, B4 is equals to 0, and B5 is equals to 4 over 5 pi. Now, with this understanding, we can recall that f of x is equals to summation from n is equals to 1 to infinity of Bn sine nx, and we can write it further to give us B1 sine x plus B2 sine 2x plus B3 sine 3x plus B4 sine 4x plus B5 sine 5x continues. So we insert our values of B1, we insert our values of B2 down to B5. B1 is 4 over pi sine x plus B2, which is 0 sine 2x plus B3, which is 4 over 3 pi sine 3x plus B4, which is 0 sine 4x plus B5, 4 over 5 pi sine 5x. So in conclusion, we can say this is and this 0. So our f of x, our Fourier sine series of f of x is equals to 1 is 4 over pi sine x plus 4 over 3 pi sine 3x plus 4 over 5 pi sine 5x. Good. Now, we want to deduce that pi squared over 8 is equal to 1 plus 1 over 3 squared plus 1 over 5 squared plus 1 over 7 squared plus. Now, let's go back to our Parseval's formula. Now, this is our Parseval's formula. And the question we are dealing with is f of x is equals to 1, and we are asked to evaluate the Fourier sine series. So the Parseval's formula we will be using will be related to the Fourier sine series. So that means we are going to be using this formula. So we can copy it and let's replicate it here. Now the question is, what is C? Okay, what is C? Now if we go back again to our set of formulas, you can say that given the range of a less than x less than b, our C is equals to b minus a. Now we go back to the question and we realize that we are given the range of 0 less than x less than pi. So we're given the range of 0 less than x less than pi. Now C will be equals to what? B minus a, and b is pi and a is 0. So C is equal to pi. Our f of x from the question is equal to 1, and our bn is what? That means we are going to be dealing with b1, b2, b3, b4, b5 up to a certain value. So we recall that b1 is equal to 4 over pi, b2 is 0, b3 is 4 over 3 pi, b4 is 0, b5 is 4 over 5 pi. So b1 is 4 over pi, b2 is 0, b3 is 4 over 3 pi, b4 is 0, and b5 is 4 over 5 pi. Now, substituting these values, or before substituting, we can rewrite the formula here as integral of 0 to c of f of x squared dx is equals to c over 2 from b1 squared plus b2 squared plus b3 squared plus b4 squared, this squared here, plus b5 squared, and continues. So let's substitute our values. 0, integral of 0 to c, and our c is pi. Our f of x is 1, as we have here, squared dx is equals to our c is pi over 2. Our b1 is 4 over pi squared plus b2 0 squared plus b3 4 over 3 pi squared plus b4 0 squared plus b5 4 over 5 pi squared. And from here now, we can now solve both sides. So solving the left hand side, you can see we are having integral of 0 to pi of 1 squared is 1 dx, which will be equals to pi over 2. And we have 4 squared over pi squared plus 4 squared over 3 squared pi squared plus 4 squared over phi squared plus this and this will be 0. So solving the left hand side further, we are going to integrate 1 with the x. So we have x with limit of 0 to pi, pi over 2, and let's repeat what we have: 4 squared, 3 squared, pi squared, plus 4 squared, 5 squared, pi squared, plus strip dot. And then when we apply our limit, our upper limit is pi and our lower limit is 0. So this will be equals to pi over 2. Now when we look at this series here, we can say that 4 squared is common as well as pi squared. Therefore we'll be left with 1 plus 1 over 3 squared plus 1 over 5 squared. So here we will have left with pi, and here after we simplify this, we will be left with 8 over pi multiplied by 1 plus 1 over 3 squared plus 1 over 5 squared plus triple dot. Now if we cross multiply on this goes here, multiply pi, and this comes here to the denominator. So we have it to be pi squared divided by 8 will be equals to 1 plus 1 over 3 squared plus 1 over 5 squared triple dot, and it can also continue according to the question. Now with this, we have been able to deduce that pi squared over 8 is equals to 1 plus 1 over 3 squared plus 1 over 5 squared plus 1 over 7 squared with the help of Parseval's formula. So the first thing we did was to evaluate the Fourier series, and from the Fourier series we applied the formula, the Parseval's formula relating to Fourier sine series. Now if the question we are given says cosine series, then we will be using this formula. But since our question is saying sine, we will be using the sine formula. So in our next video, we'll be talking on Fourier series over any range. Fourier series over any range.